Hey, Wilhelm, welcome to the Guild.
Hey, Joe. Thank you for having me.
Great to have you. The floor is all yours, and I'll let you know if we have any questions. I think we're going to do it right before the demo, but I do have the poll open. I'll share that with you then as well.
Fantastic. Thank you. So we'll get going. Today we're going to be looking at covering your apps with AI-driven test impact analysis and code coverage. As Joe mentioned, I manage the solution engineering team here at Parasoft. My colleague Adam in product management couldn't make it this morning, so I'll be walking you through this topic with a live demo of these two functionalities where you can meld and work together to sort of help you deliver confidence and speed. So to get started, let's take a look at why we would need code coverage and test impact analysis. And so if you think about it, there's only so much work you can do in each time constraint sprint. And as you advance in your testing practices, you accumulate large numbers of tests, which can become difficult and time-consuming to run and maintain. So as we go, after multiple iterations, adding more and more tests, rerunning this entire test load for each build can really slow down your productivity. So let's take a look at a quote here, right? If we can focus testing solely on changes versus the entire suite each time, that would certainly be a big win for us. And so this was a major hotelier evaluating Parasoft, and they shared this quote with us, which makes it very clear, right, that there's a time and resource saver that code coverage and test impact analysis can bring to us. And if we look at another one here, right, if tests ran infinitely quickly, we would run all the tests all the time, but they're not. So we need to balance cost versus value when running them, right? And so here, this quote from Martin Fowler gives us the crux behind why we need code coverage and test impact analysis. And so who is Martin Fowler? For those of you who don't know, he's an Agile expert, famous for a number of contributions to the Agile community. One of these is the research he and his team did to derive testing pyramid. And so the testing pyramid shows where focus should be allocated when testing, with the highest number of tests conducted in areas near the bottom, proceeding to the least number of tests as you work your way to the top. And so at the base of the pyramid here, this is your foundation of unit tests, followed by API or service level tests. These tests are much more efficient, so you should have more of them, right? And these tests can be created earlier in the software development process. They're easier to automate, easier to understand, and ultimately diagnose root causes of test failures. So as we move up, there's less of a focus on automated end-to-end UI and manual testing. Clearly, these tests have a purpose. They're very useful for exploratory and user experience testing, but it's very hard to scale them because they're hard to automate. You have to wait until the entire application and the test environment is available, and they're difficult to maintain and difficult to diagnose root causes. So that's sort of the rationale behind the pyramid here. And we also believe there's a missing layer to this pyramid, and that's code analysis. So running code analysis on your code for reliability and security should really be considered like a baseline requirement for all of your code, where you can automatically review it against good coding practices, catch code smells, and other likely bugs, where it's very easy to adopt by developers. And so following this pyramid as a blueprint helps you create that test automation strategy that's scalable. And so when we look at actual organizations and what they're doing, very often we see them identify with sort of an inverse pyramid, or sometimes we call it an ice cream cone, where a lot of testing is done at the UI, right? Either manual or automated. And it's because even though they're harder to automate, it's easier to understand and define the test plan, right? Business requirement, user interface, makes a lot of sense. And so less technical resources can do the testing, right? You don't have to be a programmer to do that. And when we dig a little deeper, we see that a lot of functionality is tested inefficiently with UI tests when it could be automated with API tests. And this is partly because testing business flows with API tests is hard to do. And API testing kind of falls into this no man's land between the dev and test roles. So the bottom line here is that many organizations are struggling to adapt their testing strategy, especially in this current climate of microservices architectures and agile development practices. So that's what we're all about, and that's we're going to be looking at how code coverage and TIA, or test impact analysis, can help address some of these symptoms we see when it comes to inefficiencies in the software quality process. So here we have a 30,000-foot view of our continuous quality platform, starting with language-based products for C, C++, Java, and .NET, proceeding through our API and UI testing solutions, SoaTest and Selenium. And what's important here is that what we're doing is we're going beyond basic reporting, and we have deep analytics using code coverage that can help to deliver real value. Things like, how do you prioritize your investments in testing where you'll have the highest impact on risk mitigation, right? We don't have a limited time to test everything, so where should we focus? Or speeding up the CI/CD pipeline, right? Intelligently choosing which tests to run based on what code is changing. Giving teams attainable KPIs, especially for legacy or brownfield projects, right? How do you measure quality today, and how do you continuously improve if it's a code base that's been around for 10 years, right? Or melting that ice cream cone, as we saw, right? And following best practices with the testing strategy. So a lot of great data and analytics. And the thing is, it's not just about having a suite of tools, right? For teams to effectively begin melting that ice cream cone and driving efficiency into their quality process, there's some stated goals that come along with that journey. Like, for example, test earlier. And so we see a lot of organizations, they want to shift quality and security to the left, get it accomplished in sprint and deliver on these priorities during development. And so while this isn't a topic for today, service virtualization is a practice that can help teams automate this component-based testing reliably and early, so they're not beholden to the state of a shared test environment. But there's also another way of looking at this test earlier goal, which is really test optimization. So here's something to think about, right? Do you as a team take the time during retrospectives to assess whether there could have been a better way to catch a defect that maybe you caught with, say, a UI test, right? And so when a defect is found with a test, teams need a platform that facilitates the analysis of whether there's a better test that can catch this defect, right? And for example, we know that developer-led testing practices like static analysis and unit testing can have a transformational impact on a positive software outcome. And what bridges the gap between development testing and QA testing is really code coverage. And so measuring that code coverage, not just from unit testing, but also functional testing, kind of opens the door for teams to start asking important questions like, is there a better way that we could be catching this defect in the future? And of course, what aren't we testing, right? You want to make sure your test coverage is good. And so next here, test faster. And so here, right, if all you have is a hammer, every problem starts to look a lot like a nail. And organizations will struggle with optimizing their testing strategy to fit within those parameters of Agile and microservices. And the inability to accelerate their testing can stem from a variety of places. So say, for example, a functional test at the UI layer, it's always going to be slower and more expensive to maintain than testing the same functionality via APIs. So some of you may be hitting some of these scalability walls with UI-heavy testing practices, and it's difficult to keep up with Agile development. And so here, right? Organizations also need a platform that enables them to efficiently build the right test, not just a test. And so this is where AI technology can assist with transitioning UI heavy testing practices to lean UI testing practices, where you can get a lot of that end-to-end functionality tested via APIs with a service there. But it's not just about writing better tests, right, and kind of improving your process that way. I mean, certainly there's some speed that you can extract there, but code coverage this is another area where code coverage bears fruit, right? You don't want to run your entire regression suite with every pull request. That's just going to be way too slow, especially as you have more and more tests. What you want to do is run the exact right set of tests that are impacted by what code changed in that pull request. And so this is what we call test impact analysis, which kind of dovetails nicely into this last goal here, test less, right? Which is what test impact analysis is helping us accomplish. And so as an organization's maturity in test automation increases, so does the volume of tests that you have. And just because you have more tests doesn't necessarily equate to higher quality, but we know for a fact that it equates to higher maintenance burden and slower feedback loop to development. So while it may seem kind of intuitive at first, Agile also means being smarter about what tests you're running, in addition to regularly reviewing those measurable outcomes to see if there's opportunities to prune tests and clean them up for the ones that aren't relevant or valuable. And so again, these optimizations all come out of the measurement of code coverage across your testing practices. So let's peel the onion back a little further. Yes. All right, so here, and this is where the test impact analysis really comes in. It helps you analyze your build, and our system determines what code changed and what tests are associated with those changes, so that we only then run those tests, which can really speed up your productivity, especially in your pipelines. And so instead of trying to run every test every single time, when we consider how code coverage can help us melt that ice cream cone, we want to look at the testing practices we have. So manual testing, functional testing, unit testing. And so what we're doing is our platform is capable of capturing the coverage from these different layers and merging them together to give you this overall coverage value. And so let's take a look briefly on what people use code coverage metrics for. And so we know that organizations will set like a high code coverage number as a goal for a metric that will improve quality. And this is because every time that developers fix a bug or introduce a new feature, they're running the risk of introducing regressions. And for many teams, especially working on brownfield development projects, high code coverage is a difficult or maybe even unattainable goal when they're trying to balance with business objectives. But the same can't be said for newly written or modified code that's within the scope of, say, a sprint or a release. And so one way we help Agile teams stay agile without impacting quality is through this modified coverage analytics. So basically, we receive build data from the CI/CD, the tests that you're running, the code coverage we're measuring, and then we let you diff between a baseline build and a target build. And so this means that even if your overall code coverage number doesn't meet the development policy that you have, you now have an attainable goal using this modified code, right? And within each sprint or within each release, right, there's no excuses, right? This is the code we just wrote, so we better be testing it, right? And now the analytics can expose that and help the teams focus on, all right, this is the code we're changing, this is the code we should test, and treat the continuous quality improvement as more of a marathon. So The next way that code coverage plays an impactful role is through test impact analysis. And so if we look at our pipelines, right, there are a lot of automation gets embedded into it, static analysis, unit test, deploy the app, right, run API tests, run end-to-end tests, etc. So this can all slow things down, right? And development wants to be agile, right? Make some code changes, push it into source control, and then as soon as possible know that, hey, I didn't break anything, I'm good to go, I can move on. And so what this does is it starts by mapping each test case to the code that's being covered, right? And then when we know, okay, well, what code changed? Now we have all the ingredients necessary to say, well, let's optimize our test execution. Let's only run the tests that are affected by the code that changed. And so you can do this for unit tests, both in the IDE and in the CI process, API tests with SOA test, and your Selenium-based tests with Parasoft Selenic as well. So across the board, test impact analysis can bring you efficiencies. Like, for example, here we've got some Jenkins trend graphs that our dev team pulled together for some runs that they did internally. So on the left, we can see over 4,000 tests running with each build. And so we turned on test impact analysis and we started measuring over a few weeks. And you can see there's a whole zero missing in the y-axis on the right here, right? Much fewer tests running because it might not be a lot of code that's changing from pull request to pull request, right? If one line of code changes, I mean, how many tests do you really need to run for that? But it's not just about improving the time to kind of run this regression with pull requests, but think about the costs associated with the computation behind the test environment, the tests you're running, leaving it up for longer. We see a lot of organizations shifting to deploy destroy workflows, ephemeral environments, right, to save costs, to do things smarter. And so this is a part of that journey, right? Is let's not run our full regression with every pull request. Maybe we do it nightly or something like that. But for each pull request, we're not losing fidelity of the testing by kind of blindly choosing which test to run and which to skip. We have a better process here. Okay, and so here's a quote from one of our clients that implemented our solution. So, with a focus on best practices for aligning traceability with test management, the team knew exactly which lines of code were being executed and tested inside of that application to validate that all of the changes had been verified. And this analysis capability, known as change-based testing, was the determining factor in the team's selection of Parasoft as a solution to support and enhance their agile workflow. So with that, let's jump out of PowerPoint here, and I'll walk you guys through a live demonstration.
And Wilhelm, before we get to the live demonstration, I just wanted to share some poll results with you. The poll we asked is, what backend languages are most people using for enterprise development? And Java was number one at 67%, .NET was 22%, JavaScript was 33%, and then everything else like Python is 22%, C, C++ is 22%, and Go is 11%. Didn't know if you had any thoughts on that, but those are the results, yeah.
Well, it kind of dovetails nicely into our product roadmap and sort of what we support today.
Cool.
So Java and .NET. And so we're looking at other languages as well and what the community and what the industry would like us to go kind of add support for. But yeah, Java and .NET are two languages that we work heavily with our customers on. So that's great to hear.
Awesome.
Sounds like this will be relevant for your community as well. So here I've got a GitHub project of one of our demo applications called Parabank. This is a Java Spring-based application. It's got a UI. It's got PIs behind it. And so what we're going to be looking at today is this whole code coverage and test impact analysis workflow. And if we look at this GitHub project, we've got a number of branches. So the master branch, and then Selenium demo is another branch here. So there's some code changes in Selenium demo that haven't been merged to the master branch yet. And so this is the basis of what we're going to be seeing in terms of, how can we efficiently validate the changes in this branch so that we know it's safe to merge to our main branch there. And so I'll first start off by kind of showing you my Jenkins jobs that I've been running. And there are a variety of things these jobs do, right? Static analysis, unit testing, software composition analysis, right? Package the application into a Docker image, deploy it, API testing, UI testing, performance testing, lots of stuff. And so what we can see if we look at these bottom two jobs, or just in general, right, we have baseline and updated. So baseline refers to the master branch, and updated refers to the Selenium demo branch. And so when I look at the Selenium demo branch testing job that I ran, it took 10 minutes to run. And if you look down here, we've got another one, the same job, but I enabled test impact analysis, and we can see a big time savings there. And this isn't a lot of tests, right? In the PowerPoint, we had big differences. I just have a handful of tests here that still are good enough to sort of show a time difference. But nevertheless, this can be very exciting at scale, right? If you go from 10 tests or 5 tests to 100 or 1,000, this could be a huge time saver for you. And so if we look at some of the tests that I ran, here I've got some Selenium tests where Parasot Selenic helps with self-healing and AI recommendations. But we'll notice that, okay, we ran 3 tests in the baseline build. So we've got bill pay, request loan, and then another one. And then if I look at the same test run from test impact analysis, we just see bill pay test ran and not any of the other tests. So what I'm going to do is introduce you guys to Parasot TTP, where we're going to sort of dig into the evidence to figure out why did test impact analysis choose to only run that bill pay test and why not the other ones. And so here, I've got a dashboard for Parabank demo. These dashboards are fully customizable, right? I can make widgets and filters really to slice and dice the data the way I need. You'll notice we've got pull downs here for baseline and target build. So it's very easy to adapt the dashboard for sprint reviews or release reviews to see how the data changes as you're comparing between builds. So first, let's just see what files changed, right? This will be a good starting point for us. Not too different from how you would look at your source control system, right? What GitHub shows you. And so here I can see that pay.java, one of the source files, changed. So right, development's doing some work here in this class. We added a brand new class, contact information, that we're referencing from pay.java. So this is the basis for what we're looking at in terms of change. So now let's look at code coverage. So here I've got our Parabank demo project. We've got the B stands for baseline, right? So this is the baseline build of the master branch, and we're looking at code coverage from Selenium tests. So if I look at pay.java here, I can see code coverage from all the testing that we're doing. But in fact, we just have bill pay tests, right? The other Selenium tests that we ran against that master branch aren't contributing any code coverage to pay.java. And because we know pay.java changed, right, and the other classes with coverage didn't change, that's how TIA is determining, okay, well, we're just going to run bill pay tests because that's what's testing the code that changed. And like I said, this works for API tests, Selenium tests, and unit tests. Right? Unit tests run fast, but if you have 10,000 of them, it's still going to take a while to get through. So this is beneficial, kind of regardless what testing practice you're looking at or thinking of. So now that we can see the evidence of how that test impact analysis workflow actually works from the CI process, I also want to spend some time showing you a bit about the analytics and how code coverage can be used in the Agile workflow. So here we can see I've got widgets for code coverage. Total means we're merging unit testing, API testing, Selenium testing, even manual testing, right? We can help organizations log code coverage from their manual testing sessions as well. And we merge it all together, right? It's not just a simple addition. There can be a lot of overlap between the testing practices. So here we know for the Parabank project at large, we're not at that 80% number, right? Let's say 80% was stated goal or development policy. And this can be, very common, especially for brownfield projects, right? It's been in production for 10 years. Users are using it just fine, right? They file a bug, we fix the bug. But, right, it's not set in stone. There's new business requirements coming in. We're implementing new features in this legacy code base. And maybe we didn't think about software quality the way we do now back then. So if we start measuring code coverage, it could be really low, right? I just worked with someone recently who told us they only had 1% code coverage, and they're making big changes to the project, and they're desperate for something to help them. And so that can be a situation for a lot of people. So what you do, right? Because if you ask the engineering team, okay, thou shalt have 80% code coverage, what are they going to say? They're going to say, okay, no problem. You won't get any new features for the next 2 years, and we'll get you that code coverage. But we know that's just unrealistic. So the compromise here is look at your overall code coverage as your long-term goal, right? The marathon goal. But then within each sprint or within each release, make sure that the code coverage for the code that's being modified is high, because that's the code that's changing. And so here we can see from the baseline build to the target build, meaning the master branch to the Selenium demo branch, 34 lines of code changed. But 29 of them were tested with the existing tests we have. So there actually wasn't a whole lot in terms of gaps in code coverage with the existing tests, which is nice. But we can drill down and, say we're a team reviewing this. We can start extracting, okay, what investments should we make to do better in the next sprint or the next release or whenever we have time. And so here I can see contact information.java. This is that brand new class that development added. And so even though they added this class and we ran our existing tests, we got some decent code coverage out of it. And if we look at the details here to see what lines are not covered, looks like we've got a method here for get email. And because I've done this demo a lot of times, I know that in the bill pay form, we added a new field for email that wasn't there before. So this makes sense, right? The Selenium test didn't get updated to fill in email address in the form. So that's being exposed in the data, right? Like, oh, maybe we should review our functional test here. And then if we look further down, we've got this equals method where some code changed here as well. And our tests aren't fully covering this. And this is the kind of code that probably is better suited to be tested with a unit test, right? So development didn't look at their unit tests to see whether them changing this equals method resulted in, oh, we should update our unit tests to fully cover the logic here as well. So really powerful to kind of use this data, peel back the onion using code coverage to work more effectively as a team. Because, right, Joe, as you said, there's only so much time in the sprint, and where do you focus? Because there's always going to be this balance between feature development and software quality. And organizations will use systems like Jira or Azure DevOps to manage their user stories and epics and things like that. So, as a business, you know where you're going and you know where your roadmap is. But what is that second pane of glass that shows you what is our quality along the way? Are we incurring extra technical debt because we're moving too fast and we're not catching and addressing bugs, with that speed? So this can be very helpful as a team, right? To use these analytics, these KPIs, so that you don't fall behind on quality as you're accelerating with Agile and DevOps and all these great things that make you move faster. Because you don't want to just move fast, right? You want to move fast and have high quality. So it's important to use metrics like these to govern your process and make the right decisions as you're moving forward. So I think last thing I'll show you guys here that's pretty neat. If we come back to one of our coverage views, let's say I drill down into this specific Selenium test here, build a test. Right, we can see my Selenium test code here. And what's nice is we also have a nice workflow to integrate with those Agile planning systems like Jira or Azure DevOps. Say this automated test failed, right? It can fail for a variety of reasons. Maybe it's a real bug, but maybe the environment changed, or some test data mismatch, right? And so the test is failing not because it's a bug. So it's important to review those automated tests. If it's a real bug, that's something that you want to have development scheduled to review and fix, right? So say this test were to fail, I could create a task or a bug. In this case, I have Jira connected to DTP, but we have other supported systems. And it links you right back to this page. So when development adds this to their next sprint and they start looking at this bug to fix, they can come into DTP, they can see the test failure, they can see what build this test was failing in. And say it was an API test, we would get request response traffic. But we also get code coverage, right? Because test impact analysis requires measuring code coverage for each and every single test case, we have code coverage for this test case. So I can see, well, okay, I know this Selenium test is failing and it's a UI test, so it's covering a whole bunch of code. What code actually got covered by this failing test, right? Now we're not looking at the Selenium code anymore. Now we're looking at the source code and we're seeing what parts of the code were covered or not covered. Maybe that'll give you some clues. But it's really nice to have that level of detail, right? How long have we known that this test was failing? Getting a test history, a lot of great details in here as well to work more effectively as a team with this automated testing practice or practices that you're building out. So with that, I don't know, Joe, were there any questions that you saw that might be better covered during the live demo portion, or do you think we're good to proceed?
I think we're good to proceed. We have a few questions, but I don't think they rely on seeing the demo at all.
Okay.
I'm sure you could always go back to sharing your screen if need be. Cool.
Okay. So to review, right, we want to test earlier, right, shifting quality and security into the left with in-sprint testing. We want to use code coverage to help bridge the gap between development testing and QA testing, using a common framework of metrics and data to work together as a team on continuous quality improvement. We want to test faster, right? Building better tests, not just having like all your testing at the UI layer and over relying on UI testing, but also, right, testing less, right? What we saw test impact analysis can do and then using the data that we're collecting from test runs to see if there's opportunities to prune tests and things of that nature as well. So this is how we kind of help organizations on their journeys of reducing the cost of quality, security, and compliance as they're accelerating software development. And before we kind of move on to questions, here you can have a voice in shaping the future of Parasoft's roadmap. Here at forums.parasoft.com. If you have ideas, input, anything you want to share, that's available for you there. And then there we go. We also have some other resources, some great white papers. If you want to read more about some of the topics I covered today, releasing faster with coverage, increasing coverage with unit testing. We do a lot in the unit testing arena as well. So helping developers double their productivity using AI to auto-generate unit tests with mocking code. A lot of great stuff to kind of dig into and look into, because code coverage isn't just, it opens the door to a lot of different conversations I've found, right? Depending on who I'm talking to. Like, developers talk about unit testing, QA talks about functional testing. And now we have this common denominator of conversation that makes it really nice to talk about the process overall, how the teams work together. So some great content here for you guys as well. And I think with that, Joe, we're ready to kind of open up for questions.
Fantastic. Great demo. Really enjoyed it. I know this is going to help a lot of folks. This is something I know my team struggle with when I work for a huge enterprise. A lot of people think run the things against all the things. It just, it just doesn't always work. I think this is a much more scientific approach as well. But anyway, enough of me rambling. One of the first questions is, in your example, is the test code in a separate repo to your application under test? And does it matter?
It doesn't matter. And it is in this case. I think we have some Selenium tests in the GitHub repo, but maybe not. I'd have to go look at it again. But yeah, for the example I put together, they're in separate repos. I think the follow-up question that you might be asking yourself is, how do we actually do it? In the sense that, sometimes testers don't have access to the source code, right, which can be a problem. So we don't have a dependency on the source code for enabling test impact analysis. We can do binary analysis of the packaged application. So say it's a jar file like Spring Boot, or maybe it's a WAR file you're deploying into Tomcat. If you have those packaged archives available, we can diff between them to determine what code changed. And then our code coverage, we're capturing through a coverage agent. So, say it's a Java Spring application. We have a coverage agent jar that you deploy with the application, and it exposes an API that you can interact with to measure code coverage for your tests.
Awesome. Thank you for that. Next question is, this is a niche question, probably, and it might be hard to answer. We use given when then Cucumber front-end technology, which is old. And I wonder if it would be possible to map our Selenium tests to the application code.
Well, absolutely. That's what we covered here today. So, I think with BDD and Cucumber and trying to bridge the gap between, say, a business analyst and a quality engineer, there's certainly some things that you can do there. But from the test execution standpoint, you look at requirements, you look at those feature files that you've written out, and you use that to determine test execution, which is a good start, right? Because then you can say, these are the user stories we worked on. These are the tests that the BAs wrote for these user stories. And then so we'll just run those tests. But there's more efficiency also by looking at code coverage directly and seeing, what code the developers are changing versus what user stories they're implementing, and using that data to optimize the test execution, which doesn't always correlate cleanly to, okay, I'm writing this feature, I'm testing this feature.
So my mistake, every time I see GWT, I think of given when then cucumber, but that was not what they were implying. They said, no, it was Google Web Toolkit.
Oh, GWT. Yes. So yeah, you're testing your application front end in GWT using Selenium. So our code coverage is on your backend code. So we're not looking at right the JavaScript that's running in the browser and what's changed there, but rather Spring application or Spring Boot application sitting behind what the browser is kind of interacting with. So it's the backend code that changes that kind of determine what tests to run or not run.
Great. So someone's asking about implementation. They say, we don't have to change any of our application code, our test code to use Selenic. I assume instrumentation builds, maybe an indication on price and maybe ROI.
So yes, Parasoft Selenic was designed to plug right into your existing Java Selenium practice. So whether you're using TestNG or JUnit 4, JUnit 5, or Cucumber, all those frameworks are supported. You don't have to change any of your test code. And Selenic is an agent that instruments the Selenium execution. So say you're using Maven or Gradle to run your Selenium tests in CI. Selenic is kind of a very lightweight drop-in, and it does some great things like self-healing and all of that for your open source Selenium tests, but also kind of makes it easier to collect code coverage because we have built-in integrations between Selenic and our coverage agents.
Great. So we have a few questions. If you have other questions, let us know. Hit up that Q&A tab and just submit it. We're running out of time, so you want to get your questions in now. All right. Well, if we have a few more questions around languages, the first one is, what language do you support for test impact analysis?
So today it's Java, and in .NET, we're bringing test impact analysis in the next release of .test. And then for kind of functional tests in the .NET arena, that's on our roadmap for next year. But because of the poll that we wanted to hear from you guys, we're looking at other languages as well, right? What's popular for backend development out there? We have a lot of customers that are working towards decomposing the monolith, moving to distributed systems and microservices. And so we're really looking at this area closely, how we can kind of adapt our offering to bring more value to some of these subjects like code coverage and TIA. So yeah, please fill in the form. Please tell us what languages you're using. We'd love to hear from you.
Great. I'm not sure if this applies to the same languages. They say, what languages do you need or do you support for measuring code coverage? Are they the same that you just mentioned?
Slightly different. So for test impact analysis, we have it just for Java today. For just measuring the code coverage in general, we have that for .NET already. And so we're adding the test impact analysis for .NET in our coming releases. But just measuring code coverage is already there.
Great. No, this is a great question. So a lot of times people don't have just 100% automated tests. So they want to know, how do you capture code coverage from a manual test? Is that even possible?
It is. So because we have these coverage agents, right, that get deployed with your application, that allows us to say, okay, well, automated tests make sense, right? They connect to the coverage agent and they do their thing. For manual testers, we kind of expose like a lightweight UI where you go in and you say, okay, I'm starting test 1, 2, 3, and then pass fail, stopping test 1, 2, 3, right? Starting the next test, stopping the next test. So it's a way for a manual tester to log their interactions on the application while they're doing their manual test. And then we capture that and publish it to BTP, just like how all the automated tests publish their data there too.
Great. So in the chat, Kelly said, great presentation. Thank you, Kelly. Awesome stuff. We have a few more questions. Wilhelm, next one is your code coverage solution SaaS, where code coverage data is sent to Power Software Processing? I know when I worked for healthcare, a lot of them like everything needs to be in-house and all that. So I don't know if that's a concern or not.
That's a great question. We get that a lot. Because we're involved in a lot of different industries, some of them regulated, some of them like government. We have a lot of customers that are very sensitive to their IP and their source code. So we are not SaaS. We're on-prem. None of the data that you measure with our technologies will leave your network, right? So it doesn't mean you can't use cloud, right? You can certainly deploy our technologies in AWS or Azure, Kubernetes, all of that. But it's within your network, within your control. Right? So you don't have to worry about this.
Now, I knew this question was coming, so thank you. Whoever submitted it was anonymous. But I want to know, what is the performance impact of the coverage agents? I know a lot of time everyone hears agents or things like that. They're like, oh no, it's going to impact my performance.
Good question. I would say, there can be additional memory consumption, right? Because, as we're monitoring what code is being executed within the application, that creates data that needs to be stored. In terms of like the performance of the application with the coverage agent, we haven't really noticed cases where, there's some noticeable slowdown or anything. But as a best practice, it's usually a good idea to add more memory to the application so that the coverage agent has enough memory to capture what it needs.
Great. Another question is, the impact analysis seems deterministic. Where is the AI, or rather, what is it doing?
That's a good question. Yeah, I'd have to get back to you on that one. I think when we look at AI as a topic, there's different ways of framing it. So there's AI, in terms of machine learning and transformers and all this stuff, neural networks. But I think there's also a broader definition of AI, which means improving or making decisions based on data that's being collected, and using these algorithms in ways that can help save time or money, etc. So I think with this one, there isn't anything in terms of like machine learning necessarily that's going on here. We do have other examples of AI machine learning workflows we've embedded in different parts of our platform. But for this one, I would agree in the sense that it's not AI in the sense that how most people would think of it with neural networks and all of that. That would be in other parts of our platform for different capabilities.
So in one of your slides, you showed a dashboard. So can people actually use it for risk to say you checked in code, you have zero code coverage against this code? Maybe the scenario you want to explore, is that a use case?
So you don't have any code coverage against the code that you checked in. Do we want to flag that? So that's a pretty popular request, I would say, is, and there's different approaches I think that people have. There's teams that want to really lock down the process and be process first, where they say, you can't merge your pull request until certain metrics are there, like code coverage or static analysis or zero test failures, whatever. And then there's other approaches where, let the merge happen, trust the team, but verify, right? So look at the data in BTP, see when the team is falling behind on code coverage for the code that they're writing, right? And make sure the team is using that effectively within the sprint. But then, in the sprint review, when the data reveals.
Hold on. I think you just, can you check your microphone? Oh. There you go.
Yeah. Can you hear me now?
Yes.
Sorry about that.
That's all right.
Yeah. And so holding them accountable that way, right, is looking in sprint review, the data is not there. And so, right, they should do something about it at that point.
Awesome. Once again, great presentation. Awesome technology. I think everyone needs to check it out. I think Joy actually dropped something more about AI, smart execution for the person that asked that question. And there'll be a follow-up email with links as well that you can check out. All right, Wilhelm, any parting words of wisdom before we end this training session?
Yeah, just if you have any questions or anything you want to know more about the technology, we're here to help. We're happy to talk to you. Anything that might come up. I've been in the software testing world for 14, 15 years now. So I'd love to talk to you, see what your challenges are, see how Parasoft can help. So Joe, just thank you for having us here. Thank you for allowing us to present this to your community. We feel that this is really valuable for organizations that are trying to do more with less. So thank you.
Well, thank you. Great technology. Like I said, I really believe in it. So hopefully we'll have you back here again to maybe do another dive on true AI machine learning, whatever solutions you have.
Yeah, I'd love to.
Cool. Thanks again. Appreciate it.
All right. Thank you.